Hello dear friends, welcome to a lecture of solid geometry. We are studying the sphere. In this lecture we shall solve some problems on finding equation of tangent plane to a sphere. In our last lecture we have seen how to find equation of tangent plane and what is the condition of tangency. We will make use of that condition of tangency to find equation of tangent plane to a given sphere. I have written here few problems. We shall solve these one by one. See, the first problem is find the equation of the tangent plane to this sphere at this point. So, we shall solve this problem, and that is a solution for 1. I shall write here. See, this is the sphere and we want to find tangent plane at this point. The point of contact is given. So, I shall draw a figure here. Suppose this is the sphere, and let us suppose this is the point of contact, that is 1, 2, 3, and the plane will be here. So, this is the plane where the sphere touches the plane at this point. We have to imagine it. The point is 1, 2, 3. Which is the point of contact. First we shall obtain the center and radius of the sphere. So why? Because we know we have to find the equation of tangent plane, and if this is the point of contact, which is A, then the distance from center to the point of contact must be equal to radius. That is the condition of tangency, and therefore this is equal to R. And for that purpose we obtain the center and radius of the given sphere. So, the equation of the sphere must first be expressed in general form. So, the given sphere is we shall divide it by 3 to make the coefficient of x square, y square, z square is equal to 1, and we write the equation as it is x square plus y square plus z square, then minus 2/3 x, then it is minus 3 divided by 3 is minus 1 y, and minus 4 by 3 z, and next is minus 22 divided by 3 is equal to 0. So, this is the equation of the sphere. We want to find the center. So, center's coordinate, its center is, and we shall now write the center as C directly. So, C is equal to, how to write the center's coordinate? We divide the coefficient of x, y, z by minus 2. We get directly the coordinates of x, y, z coordinates of the center. So, dividing this by minus 2, it will be 1 by 3. Dividing minus 1 by minus 2, it is 1 by 2. Dividing minus 4 by 3 by minus 2, it is 2 by 3. So, these are the center's coordinate, and which are, I shall write here itself, 1/3, 1/2, 2/3. These are the center's coordinate, and we have to find equation of tangent plane at this point. So, and the equation of tangent plane can be obtained by considering the center's coordinate and the point of contact. Now, we will first write the equation of tangent, that is equation of plane passing through this point 1, 2, 3. The point of contact is given, the point of or actually we don't require the radius, only we can write the equation of tangent plane at this point because it is the point of contact. So, given the point of contact is A, suppose that point is A, 1, 2, 3. So, we write, if we know a point, then we can write equation of a plane passing through that point. So, therefore, equation of a plane passing through A. Passing through A point 1, 2, 3 is, and we know how to write the equation A, that is constant, x minus 1 We have studied this in the chapter of plane. A into x minus 1 plus b into y minus 2 plus c into z minus 3 is equal to 0. So this is the equation of tangent plane that we have. But here what we require are the values of a, b, c, which will be actually the direction ratios of the normal to this plane. Now, but we see if this is the plane, then now we have proved this result that CA, which is the radius will be perpendicular to the plane, and that means it is normal to the plane, but by the condition of tangency. Now, by the condition of tangency, CA is perpendicular to the plane. To the plane, that is CA is normal to the plane. To the plane, and that is the plane 1. CA is normal to the plane 1. And now the DRS of CA we can obtain. Now the DRS of CA are the direction ratios of CA are. Now we know how to find the direction ratios, difference in the coordinates. So 1 minus 1/3, that are 1 minus 1/3, 2 minus half, these difference 3 minus 2/3, and that is, so 1 minus 1/3 is 2/3, 2 minus half is 4 minus 1, 3/2, and this is 9 minus 2, that is 7/3. So these are the DRS of the line CA, which is normal to the plane. That is, these are the values of ABC. Since this line is normal to the plane 1, since CA is normal to the plane 1, these are the values of ABC. That means we know A, B, C are the DRS of the normal in the equation of plane. Coefficient of x, y, z are the DRS of the normal. Since CA is normal to the plane, these are the values of A, comma B, comma C, and substituting these values in 1. Therefore, from 1, we have, so put the value of A as 2/3. So we'll have like this, I shall put it here itself, 2/3, and B as 3/2, and C as 7/3. So we have, this is the equation of the tangent plane. Simplify this. To simplify this, to avoid the fraction, we shall multiply by the LCM of 3 and 2, which is 6, multiplying by 6. So multiplying by 6. So what we will get, if you multiply it by 6, that will be 2 into 2, 4. 4 into x minus 1 plus, here that will be 9 times y minus 2, and here that will be 14 times z minus 3. You should verify this. That is, the equation will be, or thus what is the equation will be, we write the term of x first, that is 4x plus 9y, and next is 14z, and what is the constant that we now calculate, that is minus 4 minus 18 and minus 42. So this is you see 64, minus 64. and that is minus 64 is equal to 0. So this is the required equation of the tangent plane. So thus we have solved the problem to obtain equation of the tangent plane to the given sphere when the point of contact is given. So we simply written the equation of plane passing through this point, and then we have obtained the DRS of the normal and substituted these values in the equation of the plane. So this is the solution for the first problem. Now we consider the second one, solution for the second problem. See, the second problem is find the values of A for which the plane x plus y plus z is equal to a root 3 touches this sphere. Again here now the value of A is asked, and the tangent plane is given already in the question or in the problem. So this is the tangent plane, and we want to find the value of A, and this is the equation of sphere. So here also we shall first find the center and radius of the sphere, and we shall use the condition of tangency. I shall keep the same figure here. First we write the center and radius of this sphere, and the equation of the tangent plane is, see here, it is x plus y plus z minus a root 3 is equal to 0. This is the plane, and that is tangent to the sphere at this point, that is point of contact. So we shall write the center and radius of the sphere. The center and radius of the given sphere are. Now this equation is in general form, so we can write directly the center's coordinate and the radius. So center we denote by c. C is equal to, how to write the center's coordinate? Here we have divided by 3, but here the coefficients are 1. So therefore we divide the coefficient of x, y, z by minus 2, and thus the center's coordinate can be written directly. Minus 2 divided by minus 2, it is 1, and similarly these are the same. 1, 1, 1 is the center, and radius is r is equal to under root of sum of squares of the center's coordinate, that is a square of these. 1 square is 1 plus 1 plus 1, and next minus d. See, minus d, but d is minus 6. Minus of minus 6 means plus 6, and therefore this is root of 9, and that is 3. So radius is 3, and thus we have obtained here the center's coordinate as 1, 1, 1, and the radius is 3. CA is the radius that we have. And now we have to find the value of A so that this plane is tangent to the sphere, and we shall use the condition of tangency. By condition of tangency, the given plane is tangent to the sphere. Tangent to the sphere. If, see, what is the condition of tangency? The length of perpendicular from center on the plane. So you have to imagine it is touching this, that is we should have considered as a table, and a football is kept on the table, but there is only one point of contact, and therefore this radius must be equal to the distance or the perpendicular distance from center to the plane. So if the perpendicular distance from center C 1, 1, 1 to the plane, see, the equation of the plane is this one. So we have written the equation in general form, shifting this this term on the left side, and that is x plus y plus z, x plus y plus z minus a root 3 is equal to 0. So this is the perpendicular distance from the point and the plane, and that must be equal to radius. This is equal to radius. And we have the formula for perpendicular distance between point and plane. We have studied this in the first chapter of the plane, and we shall use that formula now. And this will be absolute value that we know it is the absolute value. Put the coordinates of these point on the equation of the plane as the values of x, y, z. So x is 1, y is 1, z is 1, and that will be 1 plus 1 plus 1 minus this term, constant term as it is, a root 3 divided by under root of sum of squares of the coefficients of x, y, z in this equation of the plane. So what are the coefficients of x, y, z? These are 1 only. So 1 square plus 1 square plus 1 square, and that I shall write 1 or in this form. So this is the formula for distance between the point and the plane. We have studied in the first chapter, and this is equal to radius. So we have already obtained the radius, and we have written here that is 3, and we shall solve this to get the value of a. So see, this will be absolute value of 3 minus a root 3 divided by denominator is again root 3 is equal to 3. So we have written absolute sign because it is a distance, and that must be positive. So therefore it is a perpendicular distance, and further we can take root 3 common from this or divide by root 3, and that is, if we divide by root 3, so this will be 3 divided by root 3, that is root 3, minus a root 3 divided by root 3, that is only a. Absolute value of root 3 minus a is equal to 3. And further from this we can see this can be written by eliminating this absolute sign. If you remove this absolute sign, then we should write this as plus or minus, because every absolute value function has two signs, either plus or minus, or that is root 3. So it is root 3, we are removing this absolute sign, root 3 minus a is equal to plus or minus 3, and therefore a is equal to, we shift a on that side and this term on left side, that will be root 3, this plus minus becomes minus plus 3 is equal to a. Or now changing the sign sides, that is a is equal to root 3 minus 3, or a is equal to root 3 plus 3. So these are the values of a, two values of a, so that this plane will be tangent to the given sphere. If you put the value of a as root 3 minus 3, then the equation of the tangent plane is obtained. Now why there are two values? One plane will be parallel to this plane, and that will be above exactly. So that in that case also the radius is perpendicular to the tangent plane, and the radius is equal to the length of perpendicular distance from center to that point. So one plane will be at the bottom, one plane like this, positions will be parallel, and thus these are the values of a. We have obtained the value of a for which this plane is tangent to the given sphere. Now the third problem solution is, see, show that the plane, this plane touches the sphere, and again we have to use the condition of tangency to show the given plane is tangent plane. Touches the sphere means it is a tangent plane. And see, we shall write again the center and radius of the sphere. The center and radius of the given sphere of the sphere are given sphere are, center we will denote by C, and directly we will write the center's coordinate, dividing the coefficients of x, y, z by minus 2 if the coefficients of the square terms is equal to 1, and that is 1. Then this is minus 4 divided by minus 2 is 2, and 2 divided by minus 2 is minus 1. This is center's coordinate. and radius is r is equal to under root of sum of squares of the center's coordinate, that is 1 plus 4 plus 1 minus d, and again you see this 3 is to be shifted on left side, that is minus 3, and d is minus 3, and minus of d will be plus 3, and thus this value is under root of, that is 9 root 9, which is equal to 3. So r is equal to 3, that is the radius of the sphere, and this is C, and center is 1 2 minus 1. And now we want to show this is the tangent plane, this is the tangent plane to this sphere, the plane is written here. So when this will be tangent plane, by condition of tangency, the perpendicular distance from center to the plane is equal to radius. So to show the given plane is tangent to the given sphere, by condition of tangency we have to show that this is by condition of tangency, perpendicular distance from the center of the sphere to the plane. Again the same condition I shall write, perpendicular distance of center C, which is 1 2 minus 1 to the plane. To the plane, what is the plane is here it is 2x minus 2y plus z plus 12 is equal to 0. So this is the perpendicular distance from the center to the plane is equal to radius. So this we have to show. Now for this purpose we shall this we have to show, and that means we shall obtain this, and we know the radius we have obtained, that is 3, and so therefore obtain this distance and show it is equal to radius. Now the LHS of this equation is LHS is equal to, see this distance we will write, and that is put this point, the same formula we have used earlier, distance between point and plane. The coordinates are 1 2 minus 1, put over the equation of the plane, that is 2 into 1. So it is 2 into 1, then minus 2 into 2, and z is minus 1, and this is plus 12 as it is, divided by, so what is the denominator, under root of sum of squares of the coefficients of x, y, z, that is 2 square, which is 4, minus 2 square, that is again 4, and 1 square, that is 1. So therefore this is absolute value of, you see this is 2 minus 4 minus 1, and that is 2 plus 12 is 14 minus 5, that is 9, and denominator is root of 9, and that will be 9 by 3, and 9 by 3 is 3, which is the radius we have obtained. This is equal to radius, and that is equal to the right side is the RHS. So we have proved this condition satisfies, left side is equal to the right side, that is RHS, and hence the given plane is tangent to the sphere by the condition of tangency. Hence the given plane is tangent to the sphere. Now what is next asked is, see, show and find the point of contact, that is the next part. So further we want to find the point of contact. Now how to find the point of contact? Suppose A be the point of contact. See, this is now the second part of the solution to find point of contact. Let A be the point of contact. Now if A is the point of contact, the equation of plane is known. This will be the normal to the plane, and we want to find the coordinates of A. For that purpose, we write the equation of line CA. And what will be the DRS of line CA? Then the line CA is perpendicular to the plane. This is by condition of tangency. Then the line CA is perpendicular. Perpendicular means normal to the plane. To the given plane. And therefore the DRS of line CA. So what are the DRS of the normal to the plane? That are 2, -2 and 1. So these are the DRS of line CA because it is normal to the plane. Therefore the DRS of direction ratios of the line CA are the coefficients of x, y, z in the equation of plane, and I shall write it as 2, -2, 1. So we have studied this in chapter 1, the plane. So these are the DRS of the line CA, and line CA passes through C point. We know the coordinates of the point C, that are 1, 2, -1, which the line CA passes through the point C. Line CA passes through C. The point is 1, 2, -1, and therefore we can now write the equations of line CA. Therefore the equations of line CA are, and now I can write here. So we have solved the first two problems. Therefore the equations of line CA are by symmetric form x minus x coordinate of C. It passes through C point. So x minus 1 divided by DRS, first DRS of direction ratio of the line, that is 2, is equal to y minus 2 divided by the second ratio, direction ratio, that is minus 2, is equal to z minus of -1, that will be +1, divided by the third ratio is 1. So these are the direction, these are the equations of line CA, and we shall suppose this is equal to R, and we can now write the coordinates of a point, general point on this line. The coordinates of a point on this line are, now we know how to write the coordinates, the values of x, y, z from these ratios, equating the first ratio to R, that is 2R plus 1, then minus 2R plus 2, and it is R minus 1. So if this point is a point, then it lies on the plane. So if this lie on the plane, if this is the point A, then it lies on the plane. Now I can write here, if this is the point A, then it lies on the plane, on the given plane. So what is the given plane? That is 2x minus 2y plus z plus 12 is equal to 0, and thus these coordinates must satisfy this equation of the plane. And then we have, see, it is 2 into x means 2r plus 1, next is minus 2 into y, that is minus 2r plus 2, and next is z is r minus 1, and plus 12 is equal to 0. We simplify this and find the value of r. So what this gives the value of r is, see, this is 4r plus 4r, that is 8 plus 1r, that is 9r, and then it is 2 minus 4, that is minus 2, minus 2 minus 1, minus 3 plus 12, that is plus 9 is equal to 0, and thus r is equal to minus 1. And once we get the value of r, we put this value of r in the point of contact, and thus the point of contact A is, thus the point of contact is A is equal to, which is 2r plus 1 etc., and putting the value of r as minus 1 here, we get C minus 2 plus 1, that is minus 1, and this is 2 plus 2, that is 4. You should check it, that is 2 plus 2 is 4, and this is minus 1 minus 1, that is minus 2. So thus the point of contact is this one, and we have obtained the point of contact. Earlier we have shown the given plane is tangent to the sphere by using the condition of tangency. So in this way we can solve problems on tangent plane to a given sphere. Now I shall give you some problems for you to solve for practice. These are some problems I have written for you to solve. First is, find the two tangent planes to the sphere, this sphere, which are parallel to this plane. Now here, so the tangent planes are parallel to this plane, and we know equation of a plane parallel to given plane differs by constant only, and therefore equation of a plane parallel to this plane is of the form, see, 2x plus 2y minus z plus k is equal to 0. So this is the equation you first write. Equation of plane parallel to the plane is this one, and then use the condition of tangency for this plane and this sphere. So this plane must be tangent to the given sphere, means find the center and radius of this sphere, find C and find R, and then perpendicular distance from center to this plane must be equal to radius, that we have used in our earlier solved problems, and by that condition find the value of k, and there will be two values of k which you can see here as 10 and minus 8. So putting the value of k as 10, we get the first plane, putting the value of k as minus 8, we get the second plane's equation. Thus there will be two parallel tangent planes, and that means if the sphere is like this, one plane will be at the bottom and another will be at the top, like this. The position is parallel or side by side like this. So therefore there will be two tangent planes depending on the two values of k. We solve the first problem like this. Now the second is, find the equation of the sphere which touches this sphere at this point, and again that sphere we have to find the equation of required sphere is different than this sphere, and condition is given that it passes through the origin. So I have written the hint here, you please try to solve according to it. First find the tangent plane to the given sphere at point 1, 1, 1. So we can we have solved such type of problems earlier. You see the first problem is of this type. The point of contact is 1, 1, minus 1, and find the equation of tangent plane, and that equation of tangent plane is this one. First get this result, x plus 5y minus 6 is equal to 0. Now the required sphere passes through this sphere and this plane, and therefore we know how to write equation of a sphere passing through given sphere and plane. So that will be combination of this, and that is the equation of required sphere is this sphere left side as it is, s plus k into u, and that u is the equation of the plane. So this will be the equation of the required sphere, and here we have to find the value of k. To find the value of k, it is given that this sphere passes through the origin, or you may suppose this as 1 and use the further condition as this sphere passes through the origin, means origin's coordinates must satisfy this equation of the sphere, and that gives the value of k. Find the value of k, and after getting the value of k, put the value of k in the same equation 1, and finally we will get the equation of the sphere in this form, which is written here. So please try to solve these two problems yourself. Thank you for watching the lecture.